We already learned mole concept. We already learned unit cells. What is the relation between these unit cells and mole concept? And see here, in today's class we are going to learn few things related to the relation between unit cells and mole concepts, especially the unit cells of sodium chloride. Let us start the first one based on highest percentage of ionic bond. Highest percentage of ionic bond is present in option A, lithium fluoride, option B, sodium fluoride, option C, rubidium fluoride, option D, cesium fluoride. Highest percentage of ionic bond is formed between the two atoms when they have a large difference in their electronegativity. More the difference in electronegativity, highest percentage of ionic bond will form. Means a strong ionic bond will form. If you consider all the four examples here, cesium and fluorine. Cesium has 0.7, electronegativity value of cesium is 0.7, whereas fluorine is 4.0. These are electronegativity values. Electronegativity value of cesium and fluorine 0.7 and 4.0. The tendency of a bonded atom to attract bond pair of electrons towards it is called electronegativity. Fluorine has the highest electronegativity with 4.0, and next oxygen has 3.5, chlorine has 3.1, nitrogen 3.0, and hydrogen has 2.1, and least one is cesium 0.7. And see here, if there is a difference which is greater than or equal to 1.7, it starts forming ionic bond. More the difference means if it is larger than 1.7, it leads to strong ionic bond. Here between these two things we have more difference, that is around 3.7, means highest difference is there in case of cesium and fluorine. That's why highest percentage ionic bond is formed between cesium and fluorine, and option D, cesium fluoride, is the correct answer. In your lower classes you already learned crisscross method. Now next question is based on crisscross method. The charge on a cation M is +2 and anion A is -3. The compound formed has the formula. In the given question they gave cation as M+2 and anion A -3. They are asking the formula of the compound formed as a result of the combination of these two things. See here, in your lower classes you already learned crisscross method. These two will come here, these three will come here. Forget about charges. And see here, as a result here we will get M3A2. M3A2 is the formula of the compound formed between a cation with +2 and anion with -3 valency. We already learned what is unit cell and what is the type of unit cell in sodium chloride. And see here, now we are going to calculate one numerical based on the mass of one unit cell. Okay. The mass of one unit cell of sodium chloride is option A 234 AMU, option B 234 grams, option C 58.5 AMU, option D 58.5 grams. We already learned that one. There are 4 Na plus and 4 Cl minus ions in each unit cell of sodium chloride. Okay. Once you check that one, the corners and faces occupied by one type of ion, and center and edges occupied by another ion. If you take this one as a chloride ion and this one as sodium ion, okay, and see here, corners, 8 corners are there, each corner contributes 1/8, then it is equal to 1, and faces, there are 6 faces, each face, see here, contributes half of that one, that is equal to 3, and a total 4 Cl minus ions. And here center, one center is there, each center contributes one complete ion. And see here, 1 into 1 is equal to 1, and edges, there are 12 edges, each edge contributes 1 by 4th, that is equal to 3, therefore 4 sodium ions. And we will check the mass of chloride and sodium ions. There are 4 Na plus ions in each unit cell of sodium chloride. 4 Na plus. See here, in the formation of sodium ion, there is no loss of mass. Only electron is going out and there is no change in the mass. 23 atomic mass of sodium is 23, and there are 4. 23 4s are 92 AMU. And chloride ions, Cl minus, here also by gaining electron, it is not going to get extra mass. The same mass will be there, that is 35.5 AMU, and here 4 are there. Okay, that is equal to 35.5 into 4, that is equal to 142 AMU. If you add both the things, here you will get 234 AMU. Mass of one unit cell of sodium chloride. Option A, 234 AMU is right answer. Now in this question we are going to link up the mole concept with ionic bond. The number of unit cells present in 1 mole of sodium chloride crystal are: option A, 6.023 into 10 to the power of 23, option B, 1.5 into 10 to the power of 23, option C, 4, option D, 1. In the given question, they are asking number of unit cells present in 1 mole of sodium chloride. And see here, 4 NaCl is equal to 1 unit cell. 1 unit cell. Therefore, 1 mole of NaCl is equal to how many unit cells? This is the question here. And see here, 1 mole of unit cell in the sense 6.023 into 10 to the power of 23 NaCl. Okay, now crisscross method, 1 into 6.023 into 10 to the power of 23 by 4 means 4 NaCl is equal to 1 unit cell in the sense 1 mole of NaCl, that is 6.023 into 10 to the power of 23 NaCl. This is 1 by 4th of Avogadro number. 4 ones 4, 1.53, that is equal to 1.53 into 10 to the power of 23 unit cells. Okay, 1 mole of sodium chloride contains 1.53 into 10 to the power of 23 unit cells. Okay, once you check the options, option B, 1.5 into 10 to the power of 23 unit cells is correct answer. One more question based on mole concept in relation with unit cell. How many unit cells are present in a cube shaped ideal crystal of sodium chloride of mass 1 gram? Option A, 1.7 into 10 to the power of 21. Option B, 2.57 into 10 to the power of 21. Option C, 5.14 into 10 to the power of 21. Option D, 1.28 into 10 to the power of 21. In our previous calculation, we already calculated that 234 grams of sodium chloride is equal to 1 mole of unit cells, that is nothing but 6.023 into 10 to the power of 23 unit cells. See here, 234 grams contains 1 mole, means 6.023 into 10 to the power of 23 unit cells. Okay, and here they are asking 1 gram of sodium chloride contains how many unit cells? Just we will go with the crisscross method, cross multiplication. 6.023 into 10 to the power of 23 into 1 by 234. Okay, if you simplify these two things, you will get around 0.025, that is equal to 0.025 into 10 to the power of 23. And see here, but it is not there in options, that's why we have to simplify this one. If you make it 2.5 into 10 to the power of 21, we can write the same value like this. Okay, unit cells. Once you check the options, option B, 2.5 into 10 to the power of 21 unit cells is the right answer. I hope you understood how to calculate this one. Very easy. 234 grams contains 1 mole of unit cells, that is 6.023 into 10 to the power of 23 unit cell. Then 1 gram is equal to just cross multiplication, and in that cross multiplication we got some value, but it is not there in options. We have to convert that one into another form according to the given options here. Okay, now option B, 2.5 into 10 to the power of 21 unit cells is the right answer.